Hey, AK again. Welcome back to video number 2 in the 1-hour Matlab series. In this video, we will explore the array operations and array indexing in Matlab. Matlab is very efficient when dealing with vectors and matrices. Knowing how to read, write, and manipulate arrays using indexing operations is an important and extremely useful skill for Matlab programmers. As usual, I'll start with the practical example to illustrate array operations. Say there is a space probe that has two transponders, okay? The main transponder and the backup transponder. The backup transponder will kick in only when the main transponder fails. Under normal operations, say the signal from the main transponder is around 4 microvolts. Okay, suddenly the space probe's control system malfunctions and it starts spinning wildly in space. The signal from the main transponder, instead of being more or less a steady signal, now shows severe oscillations. So the signal actually looks like this. So under normal conditions, we are actually seeing approximately 4 microvolts plus some noise. The failure actually happens here. The control system fails here and the satellite starts oscillating uncontrollably. Coming back to the main problem at hand. Okay, so the probe is actually spinning uncontrollably. Disaster strikes again. After a few seconds, the main transponder is actually ripped off and the signal from the main transponder flatlines to 0. But again, redundancy kicks in and the secondary transponder immediately starts broadcasting its signal. So the situation looks like this. So, operation normal, 4 microvolts approximately with some noise. Satellites start spinning out of control and this is the signal from the main transponder. The main transponder is actually ripped off here. The secondary transponder kicks in and remember the satellite is still spinning out of control. So the secondary transponder actually gives out the signal. Okay, so this is the situation now, and you are part of the satellite telemetry group and your failure analysis team captain asks you to stitch these two signals together, which means take this signal and stitch it with this signal so that you can create something useful for the failure analysis team to do some math on. So that's the task. All right. So the text file that's actually being provided to you is the satellite failure data.txt. Double click on it. This is the familiar structure that we saw in the previous video. You have 3 rows. And the first row is the time, the second row is the signal from transponder 1, and the third row is the signal from transponder 2. All right, placing a breakpoint here, running, and just step. Okay, so we read the text file into this matrix. Again, this is time, this is signal from transponder 1, signal from transponder 2, known stuff from video 1. And what we do is time, for convenience sake, I'm actually creating new variables. Time is, take the D matrix, first row, all columns. Signal 1 is again D matrix, second row, all columns. Signal 2 is third row, all columns. Okay, so we'll execute this line by line. Step, step, step. And I just want to plot the signal from transponder 1 and transponder 2. We have a new command here, subplot. Let me just explain this. Again, figure. Okay, let me execute this command and you'll know what I'm talking about. Step. Okay. So what this actually is done is we need 2 rows in this figure, one figure, 2 subplots, that's what it means, and 2 rows, 1 column, and this one means the first figure. Okay, so what you have done in the first subplot is we have plotted time versus the transponder 1 signal. All right, and you know where this is actually going. Step, 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 and this is subplot, 2 rows, 1 column, the second subplot. We have plotted the transponder number 2 signal. All right, so this is not very difficult to understand. Okay, now we come to the important part, which is the find command. All right, so before I execute this line, I just want to give you some graphical explanation as to how the find command works. So let me go to Photoshop. All right, so the Matlab find operation. In order to understand this, let's actually start with a vector V. Let's say this has 5 elements. You know, this is the first element, second element, third, fourth, and fifth element. This is the index 1, index 2. Note that the index is not the same as the element. Index is the place value of this element in this vector. So this, what we're saying is, index 1 means this is the first element, index 2 means this is the second element, index 5 means this is the fifth element. And moving on. So if we execute the command, if we ask Matlab to find the indices of all the elements that are greater than 4.0, what will happen is, okay, so Matlab's answer will be index 4, index 5. So what Matlab will do is, okay, it will come to the first element and it will check whether this element is actually greater than 4, which is not. This element also fails the test. Third element also fails the test. The fourth element is definitely greater than 4.0, so its index, which is number 4, 1, 2, 3, 4, will be part of the answer, but it is not the full answer. So the Matlab will keep continuing and it will say, okay, this element is also greater than 4, so it will, the answer will have index 4 and index 5. All right. Now we can qualify the find command with the condition saying that find the index of the first element that has value greater than 4.0. In this case, Matlab's answer will be, it'll keep on checking the condition, and when it reaches the fourth element, this element is greater than 4.0, it will return the index, and that's it. Matlab will give you the answer as 4 because you have qualified the find command with the condition that give me the first element that has value greater than 4.0. Okay, now that we understand how the find command works in Matlab, let's get back to the Matlab window. What we are saying is, we are defining a new variable called index, and we are saying take signal 1, which is the transponder signal 1, okay, and find the first element. Okay, if I bring in, okay, this is the transponder signal, signal from transponder 1, and find the index of the element which has the value 0. That's what this command means. All right. Once we do that, we create a truncated version of signal 1 from start to the failure time index -1. Why -1? We don't want the element, we don't want the index where it actually goes to 0. We just want the index, just one index before transponder signal actually goes to 0. So we want to snip the signal from this index to this index. That's what this statement, this line is actually doing. We are creating a new vector. Signal 1 truncated is signal 0, 1, which is the original vector, and you are taking part of the vector that starts at index 1 and actually goes up to index -1. Index, you know, we found it using the find command, right? So what we're doing is we are snipping, cutting the signal from this point up to this point. So that's signal 1 truncated. And signal 2 truncated is we take this signal 2 and we truncate from this index up to the end. So what we're doing is we are cutting the signal 2 from index, which is this one, up to the end. All right. Okay, now we are creating a new vector called signal new, and we are actually concatenating signal 1 truncated with signal 2 truncated. Okay, I just want to show you. Okay, step. Okay, all right. Some interesting stuff here. If you say, if you type in length signal 1 truncated, it actually gives you answer 129, which means it signal 1 truncated, which is from here to here, we have 129 elements, and signal 2 truncated has 171 elements. So if you combine this with this, we should have 300, right? So 129 plus 171 is 300. So what you have actually done is we have taken one truncated vector and we have concatenated this with the other truncated vector, and we actually created a new one. All right, and we'll actually create a new figure and plot the new signal vector. So step straight on. So this is how the new vector looks like. So we have actually taken part of the transponder, the useful part of this transponder or signal, and we actually concatenated this with the useful part of the transponder to signal, and we actually created a new signal. You know, that's what this plot is about. And the final plot is, it is just a sanity check. I'll actually show you what's actually going on. Okay, so what we've actually done is we are actually over plotting. So first we plot the signal new, which is this one here, the concatenated signal, and we're actually plotting signal 1 in black. There is a new command here, it says hold on. So what we are saying is we plot the first signal, and if you don't type in hold on, when we do the plot again, the first signal will actually disappear. So this actually holds the plotting, so we can overplot. So hold on means it helps us to overplot. So signal 1 is actually plotted in black. It actually comes down here, and signal 2 is actually plotted in blue. So they're actually right on top of each other. So we know our snipping operation, and snipping and joining operation has gone flawlessly. All right, so that's it for this video. I hope this was useful, and we will meet in the next video. Thank you.